Hello and welcome back to the Talos Linux Install Fest. It is currently July 22nd, and I promised everyone that the Talos Linux Install Fest was going to end last week on the 18th. But we have some other streams to do. We have other people that were interested, and we had some reschedules. So we're continuing on with the live streams and these Install Fests. Thank you everyone for joining. If you are joining live, please drop us a comment. Let us know you're following along. This stream is all going to be about installing on OpenStack. So we're installing Talos Linux in a OpenStack environment, which is going to be similar to if you run OpenStack yourself, you're using a host provider, whatever it is, the OpenStack commands are roughly going to be the same, and the workflow is going to be the same. Typically, we've been having first-time Talos users help walk us through these things, and in this case, this is not a first-time user. Pepine Omen is going to help us. He's actually been giving talks about Talos at different conferences. He is a very familiar Talos Linux user and has been telling people about it, and was grateful or thankful enough for him to come on and show us with an OpenStack environment. So let's bring him up and just do a quick intro and we can get started. How's it going?
Hi, Justin. I'm great.
Thank you. Thanks so much for coming.
No problem. I'm glad to be here.
And first I want to drop there. We're doing this on top of Redpill Linpro, and you work there, right?
Yeah, I work at Redpill Linpro. We are a Norwegian Nordic company having offices in Sweden, Norway, and Denmark. We are providing consultancy services and cloud services to customers in Norway. We have our own semi-public cloud, which can be used by our Norwegian, Swedish, and Danish customers, and where the specific thing, our unique selling point, is to provide Norwegian-based services, so that people that are GDPR affected by GDPR rules know for sure that there is a European Norwegian company taking care of their data, basically.
So it's a localized cloud for people in the country.
Yeah, based in the cloud itself is based in Oslo, in Norway, and I'm part of the company that runs this cloud, and we run this cloud on OpenStack, and we also have an OpenShift, or better, an OKD, the open source version of OpenShift, offering to provide this with Kubernetes-based applications. But of course, we also use Talos Linux a lot for a number of customers who just want the Kubernetes part and not the multi-tenancy part of an Kubernetes installation, which we provide through OpenShift.
Got it. And I was also going to share your recent talk at StatConf, talking all about like why Talos Linux, why people might want to use it.
Yeah, this is a talk I've been giving at different conferences, but this really an introductory talk, just showing what Talos Linux is, why you want to use it, what it is providing, and I'm also then demoing a quick OpenStack installation. But the thing we're gonna do now is a little bit more extensive than the thing that's done in the talk, because it's just 10 minutes and you don't have time to do the complete setup with the load balancer stuff and the like in a talk that's only 30 minutes, where you want to use half of the time to introduce the whole Talos Linux concepts.
Yeah, for sure. And for anyone else that if you are following on live or recorded, if you're watching this after the fact, here's the doc we're going to be following. This is the install guide for OpenStack. Again, this is a generic OpenStack installation, but it does work on basically any cloud that uses OpenStack under the covers.
I'll make some comments about the specifics I know of that might affect you when you're doing it on the different clouds, because the issue with OpenStack, it's a really enormous product. It has a lot of different components. It's hard to set up, actually, to do all the things right, and you're not required to have all the components in there. For example, the load balancer stuff that's done in this documentation is using a round robin. We need to change that because we are not providing the Octavia load balancer. We only use the OVN load balancer, so we need to do some small adjustments to make this actually work. But basically, OpenStack is an KVM-based virtualization technology on Linux. Red Hat is providing this as the Red Hat OpenStack P product thing, but it's based the same stuff. It's OpenStack in the bottom, which consists of all the different elements that make up a cloud provider.
Now you have a lot of experience here with OpenStack and Kubernetes, and in layering those two things is not less complicated, right? Like there's more complications when you're doing both of them. But as far as maintaining and managing both, which one do you like? Because OpenStack is, again, it's an infrastructure VM based environments, but you do get storage. It is kind of, it's a VMware like environments, or a cloud like environments. And Kubernetes is mostly focused on applications, but they're starting to shift some things more infrastructure like, load balancer management, KubeVirt VMs, that sort of stuff. Where do you think the major differences are?
The scheduler, I think. The way Kubernetes handles applications is quite a different concept. OpenStack is a virtualization toy, and Kubernetes is a high availability application toy. So for OpenStack, you typically move your VMs to different hypervisors when you're gonna do maintenance, because those are snowflakes. While on Kubernetes, you make sure that all your applications are running with multiple replicas, and make sure that they don't run on the same nodes, which you hopefully have on different hypervisors as well, so that when you get a failure, the application is just running. That's a different concept. That's really a different concept. In the same, the whole decorative nature of Kubernetes also is very different concept than the traditional running your VMs on a virtualization platform. And that's really not just OpenStack. This is true for all your traditional cloud provider platforms. It being AWS, Azure, G-Cloud, or GCP, or OpenStack.
Yeah, for sure.
Or all the others, DigitalOcean, etc.
Well, let's go
what I'm thinking about is that we should basically turn this whole thing around and have Kubernetes in the bottom with KubeVirt on top. But my colleagues are not quite there yet. This I think is the future.
Let's go ahead and pull up your screen. Here we go. And Indigo VFX. I saw. I'm sorry, I have been forgetting to switch these streams to 1080p. That's my fault completely. We upgraded our StreamYard account, which by default the Pro was only 720p, and you needed the whatever the top tier was for 1080p. But because I created all the streams originally, I had to go into each one and change the settings, and I kept forgetting to do that. So hopefully we have 2 streams today, and I think one tomorrow. They all should be 1080p. So we want to not strain out your eyes when you're trying to read these screens.
Just hope that the screens on my side are big enough to be able to read it, and just say.
And I don't know how StreamYard when you're joining, right? Because I don't know where it restreams to become 1080p, or stream it down, since we're having people join from all over the world. I don't know how that actually works. But let's go ahead and jump into
this. Is the start of the documentation. I thought I'll just to show you the way to where the OpenStack is as well, which is under the Talos Linux Guides installation. And this is of course a cloud platform we're talking about, and it's one of the cloud platforms down here. It's OpenStack.
Yeah. There's a very, very large overlap between virtualized platforms and cloud platforms. But we really, it's we try to say cloud platforms are either something that's hosted or something that is more than just a virtualization layer, right? Because there's things that are here's a VM, now do everything else yourself, where OpenStack has a lot of other components.
And the load balancer is, of course, one of the main issues. The thing that is not being shown in this setup, and I'm not sure, I didn't look at the other ones, but is the integration of the Kubernetes stuff with the cloud. So the cloud provider stuff, which I've been working with as well, which has some nice extra functionality, because it makes your Kubernetes cluster, your Talos cluster, more aware of its environment. And gives you the opportunity to schedule to use persistent volumes and the load balancer stuff. This is not something we're going to do now. We're just going to get up a cluster which is just living on its own within our OpenStack environment.
Yeah, and that's something I have on my list of to-do items, to add all of those cloud providers to these segments, on like either link out to how to install them to integrate the rest of the way, or because volumes, load balancers, there's various things that you might want to integrate to make your applications just integrate better. Can you make the screen a little bit bigger? I can read it, but we have 1080p, but yeah, always helps. One more.
Does it did?
Not get rid of the sidebar.
Really
that's good.
Big. No, it's getting really big.
It's really big, but
that's okay.
I've been doing streams long enough now that I feel like I have people that join from phones and they just want to watch it casually or something, and I just always try to make it as big as possible. It's like, as soon as you say that's too big, we'll go one back, and that's
okay. Was this too big?
No, this looks good to me.
this is good. Okay. So the image, I did download the stuff and did make an image already so that we have it available. It was uploaded because this is something that takes a little bit more time, not so much for Talos because it is so small.
Right.
But traditionally,
it's not gigs of data, but it's large.
No, but it still is. There's a network infrastructure that needs to be present within OpenStack. This is something that you, if you have a project within OpenStack from scratch, you have nothing. You need to set up a router. You need to set up a network and subnets. I did this. This is the OpenStack GUI. So I did set up a router, which is here in the middle, which is connected to our external internet, the internet, which is the blue one, and on the inside it has a network, and in that network it has one subnet, which is an IPv4 subnet. Keeping life simple, not introducing any IPv6. It's a bit of a shame that we're still in a world where IPv6 is not something that just works, but that's how it is. And to just keep things simple, we just use a single IPv4 address. And that also means that we need to use floating IPs. If we would have used IPv6, we would have direct access to our VMs through IPv6. You don't have any floating IP stuff. We do provide IPv6, and I do have IPv6 from my home office as well. But just to keep it simple, I removed the IPv6 part. So this was pre-provisioned in front.
I literally, it's one of the things with IPv6 that's interesting is just that the subnets for IPv6 are just so large. Like, we can't really wrap our heads around like what is going on here. And I remember at Amazon and EKS, like the IPv6 stuff was, I forget what the slash was, but it was more than all of the IP addresses of the internet, more than 4 billion IP addresses per node. It's just like, oh, we just have a lot of them. So just like, just give it 4 billion. Who cares? I'm like, that's more than the internet has. Like, what are we doing?
Yeah, man. Well, you see how the number of devices has exploded. I mean, my home.
Well, yeah, I mean, I open my Wi-Fi scanner and I see every printer and refrigerator and oven that any one of my neighbors has, and I'm just like, actually, maybe not all these need to be on the internet.
Which is also a challenge with the IPv6. I mean, you basically, if you don't take care of your firewalling, you basically allow everyone in. That's the nice thing about floating IPs, actually. Okay, so now we need to set up a load balancer. Here is one of the things that now we're going to start out with, making our network infrastructure and set up the load balancer. If we take the first line, it just creates the load balancer object. But the thing we need to do here, is that we actually can use the network ID. And in the diagram you saw that was called the internet. So the subnet is just the subnet from the ones that you have available. This provides us with a load balancer that's available directly on the internet and gets an IP address from the internet.
Could you make that font a little bigger too?
Yeah. That's what happens when I make it bigger, but it was on my pre-done stuff. So now we have the load balancer itself available. So we're going to create a listener. The listener is the thing that actually allows us to communicate with the port. This is the outside side of the Kubernetes protocol, because the load balancer we're going to use for the Kubernetes API, just for the Kubernetes API. Talos itself, we access directly through floating IPs afterwards. So the 50,000 is directly, the 6443 is done through a virtual IP provided by OpenStack. The alternative would be to let Talos provide the virtual IP, but that requires some patching of the configuration. So you can choose, both work, but I actually prefer to have the load balancing done by the cloud itself. Makes more sense.
Instead of changing the configuration for Talos, make the load balancer do the swap. Accept the expected port and then rewrite it.
Yeah.
There's always options there. I wonder. It's like at some point I want that, and then sometimes I don't. Right? It's just like when I'm debugging something, I want less magic, and when I'm setting it up, I want to save the defaults as much as possible.
This is not working because this is the thing I was talking about. It's not working. Right? This there. So I just had to refocus my screen a bit. The thing that's not working here is the round robin. We see that the OVN provider does not support round robin.
Okay.
The thing we need to put here is source IP port or source IP. But when we're doing it, it's just this is the way it uses affinity against the machines it goes to, and it makes sense to have the connection. Keep the connection from the same source IP with the same port going to the same backend, as long as the backend is healthy, of course. So
right, what happens there? Because like
take the
round robin, I hit the load balancer, it's just going to cycle me through all the API servers. Source IP port, I hit the load balancer, and then one goes away. Does it automatically fail me over to something else and just makes my connection sticky there?
It will, yeah. So it will do sort of the same as round robin, but prefer to stay at the same one as long as it is available. When it falls away, it will change. Doesn't really matter. The API is redundant enough to, or not. Doesn't really care about affinity, so it will work. But round robin doesn't work because the type of load balancer that we provide doesn't support the round robin part. That's basically the reason why I changed it. And the next one is the health monitor, and that's the one that's of course very important to have, because this is the one that makes sure that the port is actually monitored, because otherwise
right. Otherwise it never knows it's not healthy.
It doesn't go away. So here you can change the delay, max retries, and timeouts to, if it doesn't fit your scenarios, to be faster. But if you have more shorter delay, you will have more pulls to the backends.
And of course, here in your output, I see like operating status is offline. Like we haven't made any machines yet. This is just like
nothing.
Load balancer exists and is going to get ready. It's going to start health checking on that network for those ports, but there's nothing there. So.
So now we're going to create some ports. There's a small issue here. Why is it? Okay.
As a shared network,
man? It's not doing exactly what I expected it to do, but we don't have a network called shared. We have a network called Talos. So we need to create one for the first control plane node, one for the second control plane node, and one for the third control plane node. And this is the ports. Creating ports usually is done by the creation of the server itself, but in OpenStack it actually makes sense to decouple those and have the port created manually decoupled from the server, because this means that you can delete the server and keep the MAC address and IP addresses that the system uses. So you have one less thing that changes when you replace your server. You can just throw away the server, reuse the port, and still use the same MAC address, IP addresses as the original one did.
So that exists at that exists at the network layer and always is stable, and the machines just connect to it. Okay.
Yeah. So we see that when we create the servers, that we're actually gonna use the port ID to create them instead of get them allocated dynamically from the network. Now we can also, and this is probably the reason why this was done, create a floating IP on those ports. They again need to be taken from the internet network. So now you see that we use the port that we created and we attach a floating IP to that port. We do it for all 3 control plane nodes, and we just do it for the control plane nodes. The worker nodes really do not need to have any floating IPs available because you do not need to access those directly. The floating IPs are basically used for the gRPC API for Talos. And that's where they're used. For the Kubernetes part, we have set up the load balancer, and for the worker nodes, we actually use the Talos ETL. If we use Talos gRPC API, and then it is provisioned through the control plane nodes from Talos into the worker nodes. So they are just they don't need to be directly exposed because you have a proxy through your gRPC API endpoints.
Right.
So the endpoints versus nodes thing. That's basically what we do here. So now we have done that, we're gonna associate the ports that we created to the load balancer. To do this,
we have to look up those IPs.
We need to look at the IPs that are used, this is the port. I use the OS command, which is an alias on my machine for OpenStack, because OpenStack it's too many. I see people that use just the O. For kubectl, I use the K, but but for OpenStack,
I have so many single letter aliases. I'm running out. Like
exactly. So we have the OS, the port list. If we now create the load balancer entries, we need to replace this with the IPs of the different nodes, and those have been assigned by DHCP on the network, and the shared subnet that's called Talos _ IPv4. That's what I called it. And now we just need to remember.
So your network was Talos, your subnet is Talos IPv4.
Yeah. Could have called it Talos, but when I want to introduce IPv6, it makes sense to have a name that has the
Why did we get
protocol type.
What took the .1 is probably your gateway, isn't it? I was looking at those IPs; they're not in order because it's like we got control plane 1, 2, and 3, but its IP addresses 2, 3, and 184.
Well, you see here that this is the gateway. This is the first DHCP server. Then this is the DHCP server on 2.
Okay. 235. Yeah, 3, 235, 184.
Yeah, 184, and then. So now we have added to the load balancer. In the load balancer we have a pool, and the pool has members, and the members are now allocated to the ports that we created. We still do not have any servers. We just have ports, and so this is still network infrastructure stuff.
Yeah.
Okay, security groups. It's not really what I want. What I did with the security groups. This is security groups we have. There are 2 implicit groups that are CO is for Cloud Ops, which is the part of the company I'm working for. These are the upstream security groups that we use for monitoring stuff, and our monitoring systems can be used if you want to use them. But the one we're interested in now is just the ones in the default security group. And here I opened up the complete internet for 6443 and 50,000. It's not really what I want to do usually, but just to make it easy, we just open up this. And this is what it describes here in the configuration, in the documentation as well. Use the Kubernetes API server 6443 and open up for the Talos gRPC API for 50,000.
Now, when you open up the load balancer for 50,000, but if you hit that endpoints, you don't know. I guess you would be sticky at this point because we're not using round robin. We're always sticky to the same actual machine that's behind it. But how would you route to the other ones? They don't have.
No, it's the floating IP. We have the floating IPs, and those are connected. So we have 4 addresses now.
Because those floating IPs are public on the internet as well.
Yeah,
that's what it is.
Okay, the floating IPs that we have 3, and if we have to look at the load balancer.
And those floating IPs, there's your public IP addresses.
So here we have all the IP addresses that we have now exposed publicly. This is a range that we have available. We still have IPv4 addresses available in a pool. They're costly, but I was allowed to use them.
But if you're doing
we use 4.
If you're doing Talos control commands to those endpoints, you would want to use the 87 addresses, not the load balancer. So you make sure you hit the right one.
Yeah. And it was you don't know which one you're hitting. So
right, if you're going to load balancer,
we just had then that's why the load balancer is providing 6443 and not 50,000. The load balancer is only configured now for providing 6443, which is the Kubernetes, which is okay.
Right.
So
the security group allows 50,000, but the load balancer is only 6443. Yep. Okay.
Yeah. So if we look at this command, not this command. This command.
I always forget the keyboard shortcut to delete. What's your terminal keyboard shortcut to delete before your cursor?
Control W.
What, the Control W? That's an Emacs mode. That's right. I gotta set that up in Vim mode. Okay, Control W. I always forget that one, and I don't have it configured. And I'm like, I always just backspacing like a.
when it changed to, I used to use in the cases what I did now. I used to use Control U, but in Z shell it just removes the whole line and not from the cursor to the beginning of the line. And I'm too old to learn all new commands. I'm just sticking with a few. I learned Vim one time back in the 90s too, because all Unix systems had Vim. So what we see in the documentation is it actually uses JQ to do this, but there's a nice trick. I'll submit a merge request for that.
Is that like a F value, like filter value or something?
That's what we're going to return, and the column we're going to return. How are we going to return? Which format are we going to return? Value, and which column are we going to return? VIP address.
Okay.
So now we just get the IP address, which is, I think, better than the whole FJSON JQ stuff.
I agree.
Because now you just use the OpenStack command itself, and you have one less external dependency. So now we use the Talos GTL part. And just do it like this. Why should we put it in a variable if we just can do it directly? And now Talos configuration is created like usual for all your other platforms. Don't really need to talk too much about it. I do prefer to use a secrets on the side. Basically the same as why I create the port separately, because the secrets is something that's nice to reuse. At the same time, this is the hard part. You need to be very protective of it. But now your secrets are in your control plane worker anyways. So I do like to.
That? Would that be like, so if we strip out the secrets out of the control plane YAML and we put that as like, do we put that as metadata secret for the node itself?
No, what I do then is I just use the gen secret to create the secret YAML file, and then use the generate and tell it to use the secrets file itself. It doesn't really change anything in the end product, but it does give me the opportunity to reuse the same configuration files, the same CAs, the same.
You mean for the files themselves, pull the secrets out. But when you create the machines, I was actually looking at the command there. I saw there's the user data at the end. Okay, yeah. So you're just sending the user data is.
Yeah. So this is, you might of course use the more traditional, the insecure option, and just start your Talos machine, not specifying anything, but the fact that you can use a user data makes it much easier, because it is sort of provisioned, more ready provisioned.
And I mean, that is a common thing for people, like, oh, I'm just going to start it up off the normal generic Talos thing without user data. And at that point, it goes in insecure mode, and you're listening 50,000 on the public internet, right? So it's like if someone randomly found port 50,000 on your IP address and sent machine config, they now own that machine because they're the first ones to say, here's my secret, now you trust me. And so you have to restart this stuff and go through it again. But yeah, like giving it user data up front never goes into the insecure maintenance mode. It always has security from boot, and you don't have to worry about that side of it.
Yeah. So now we're gonna run this one, and here we need
to change that path.
Just need to. Because I need to do some changes here. Not sure why.
Is your shell in VI mode or is it in Emacs mode? Do you know?
I think it's in VI mode, but
if you
don't
hit,
really dare to say. I do the escape back.
I was gonna say do escape and then V. Does it go in visual mode for you? I don't know if that's a setting that I have.
No.
That doesn't do anything. Okay, that is my config.
So the things I need to change here. The path is in path tool. I am in the current directory, so the user data is control plane. The image I called Talos v175 because that's what I called my image. I like to have the version number in it. This is okay, and the flavor is very cloud specific. M1, yeah, that's probably a standard, but I have a flavor that's called GXCD. Which stands for generic anything. We have generations of machines, and if I specify generation 5, I get some really nice new CPUs, and if I specify generation 2, then I get the very old stuff, and if I do an X, I just get what fits my anything. It might be very slow, but we don't notice it, especially not in this. So there's that, and then done. So we now generate 3 control plane nodes, and they use the NIC port ID stuff to connect to the ports that we created before.
Oh, okay, yeah, because they're named the same there. They just have iterators on them. So okay.
And so now we create, just for the fun of it, also worker node, which we need today to do the same small end changes.
And that image is what you uploaded at the beginning.
Yeah, and the name I gave
right
at beginning before we started earlier today. Or there's a network here. We have the network that
Talos.
The other ones I used ports that were created. This is Talos as network. So we can now look at the servers we have.
Does OpenStack have the idea of availability zones by default? Like, are those 3 machines you created? Are they in three different AZs, or how does that?
No.
It's one data set.
It does have the concepts. We can look at the single one. We have 3 availability zones, failure domains, separate data centers across Oslo. Don't hit Oslo with anything strong because that's gonna be a problem. But an airplane will not take out all 3 data centers. So.
But it's not a virtual partition like GCP had when they had their, where was the fire that took down 2 AZs, and they're like, wait a minute, this isn't 2 actual data centers. This is like one.
No, this is,
we
have 3 actual data centers.
Yeah.
Or we're not the owners of the data centers. We just rent space in data centers just to. This is OSL 2. We have one OSL 2, OSL 3, and OSL 4. OSL, the name from the airport is OSL. So the 3 letter name combination. So if we do expand internationally, we're gonna use the airports in the neighborhood. So this is in one availability zone. Yes, it's 2, and 2 is actually in the same. So I didn't tell it to split over multiple availability zones. I just let it choose for itself where it had any available space. I can use something called server groups, where you can use anti-affinity to make sure that it spreads over.
How would that work with the networking? So the load balancer probably could spread.
The networking is the networking. The load balancer is split over multiple availability zones. This is stuff that your OpenStack infrastructure people need to fix. The load balancer is 5 elements that provide the load balancing server to my VMs.
What about the networking, like the subnet? Is the subnet AZ specific?
Subnet is cross. It's VXLAN running over across the data centers.
Okay, so the subnet, you only need one subnet to go across all 3 as well. Yeah. Okay, cool.
And we have a ring between our data centers, so you can't dig out one cable and then take down everything and stuff like that.
Interconnectivity is important.
My main customer, I'm a consultant for a major publication company in Norway, has the concept that we have everything set up with Talos Linux in 3 data centers, and the idea is that we can take down a single data center, lose a single data center, and still be able to provide news to the Norwegian population without noticing anything.
Yeah. Cool.
So no CrowdStrike single point of failures there. Okay, now we have the workers, now we have the servers. One thing we can do now is to look at the console of Talos control plane 1. No, what did you call it? Control plane 1?
Is there a dash between control and plane?
Yeah.
Yeah. It's not one word there.
Always there. And this is just the kernel log output, where you see the stuff that this is still waiting to be bootstrapped. Everything
Right.
seems okay. We can also, just for fun, change this to URL shell. And then I like to add the value in the C URL. This provides.
I was like, in curl? Why are you curling? Oh, CURL. I see. Column URL.
C URL. And I remember it by curl.
That's amazing.
It would be nice to be able to use curl now. And if we do now, then we get the console itself in a web-based console. So here we see also that it's booting and basically the same. So if we now go back to
websites pretending to be terminals is always fun.
Yeah. So now use the endpoint. And the endpoint we can use is now presented in this log here. This is just one of them.
Yeah.
I do actually not need this part here at the moment because I export a Talos config, which is Talos config. So my environment contains a Talos config, which is the file that is in my current directory. So when I change...
Oh, you always permanently set that?
No, I use envrc for per... But in this case, it is set. So
if you're in a directory that has the Talos file, it uses it.
No, actually, that's not that much. I do that with OpenStack stuff, but not with... I just do it like this. So both the kubeconfig and the Talos config.
When you go into
because I have so many Kubernetes clusters to maintain that I have kubeconfigs locally, and I just change directories to change project. But we don't have a kubeconfig now yet. We have a cloud YAML. I didn't.
We haven't bootstrapped yet either.
We haven't bootstrapped yet. No. So let's bootstrap. Let's bootstrap. So now we can bootstrap.
It's just Talos control bootstrap because you already set your endpoint.
Yeah, but I didn't specify the node, so I need to specify the node. Not like this. I can remove the config there.
Yep.
So I can do it like this. I need to tell which node to use because I didn't specify any nodes yet. And now we should actually see on the console here that it was running healthy. And now we just need to wait.
Yeah, there's your bootstrap requested.
There's the log line there. Of course. Yep. etcd members should be okay now. They're already all 3 already in. I really love this stuff though.
Being able to see the all of the etcd and the resources straight from there.
So now we can retrieve a kubeconfig, and we can run, not yet, but soon. Actually, it is already returning.
It's already the API server is already up.
Something is up enough to already.
It responded.
Yeah. It doesn't have any nodes yet. It doesn't have any pods yet, or.
Yeah. We don't have a scheduler or a controller manager. So
no, it is still
the other components right there, but we have an API server that is at least responding.
And now we can, of course, also use dashboard from here too. And now we're just looking at that single node. We could add the other nodes as well. They are available. But as soon as one endpoint is available, you basically have access to all.
You can do stuff. How is this? We have a ticket right now for the dashboard not working in light mode. And now I'm trying to figure out why yours works in light mode. I gotta dig into that. It might be certain terminal emulators. It like completely washes it out, like or it's just certain themes don't work.
It's a bit light though. It's a bit light, but
yeah, it's lighter than what you have here. But I don't remember what framework we use for that dashboard, so I need to dig into that.
Okay, so if we now look at the, I lost my mouse. No, it's that.
Yeah, everything is healthy. We'll probably see in a second here the logs fill up with the CNI actually get deployed. Because if you look at your pods, they're probably not running yet, or they're downloading. They're scheduled, but not.
Now and the stuff should be up.
I mean, yeah, but like this is the CNI all there? Oh yeah, all running.
That's also a thing. I don't use Flannel as my standard CNI. I use Cilium, and I've been trying to figure out how to put in Cilium and have everything. I've been looking at Omni, and I've been looking at Cluster API and how to provision more. And this is not really OpenStack stuff. At the same time, the Cluster API is really OpenStack because you have an infrastructure layer that's done by the Cluster API. Provisioning on OpenStack, and then it's nice to have all your CNI and external cloud configuration done at boot time.
Yeah.
So that you don't have to do it in a phase 2.
Yeah, it just helps you template out those really quick and just say, "Oh, I have a cluster; it'll come up." There's your.
So here we see now that we have the VMs there. We have the load balancer stuff. There it is. This just gives you a UI view of all the stuff. I love the command line; it's so much faster. So I don't usually use this GUI UI stuff though. Well, that's basically it.
Cool. That was smooth. I mean, that's like that's what we want, especially as you're already experienced with Talos. I didn't expect any surprises there. I learned some stuff about OpenShift, or OpenStack, which is great.
So, that's I mean, when we started using OpenShift, this was really a problem that people were calling. You did use OpenStack already, then we started using OpenShift, and the mix up of OpenShift and OpenStack,
like 70% the same word
all the
time. Yeah. You can't even alias. Yeah, the OS is like, wait, which one is this?
Yeah, that doesn't work. No. OC it's called for open.
Right. So cool. Well, thanks so much. This was great. It was a painless walkthrough, and like you said, most of those steps there, once you have like the Talos config files, it's like it's the same. It's like, okay, when I would use
the tricky part here was actually the load balancer and getting around how is a load balancer working, how in OpenStack the members and the listener and the health monitor and how are all those components. But the documentation from which is on the website is really great. It just just do it said there. And
the most confusing load balancer setup I've seen so far was GCP, because GCP had like different terminology for like backend service and how the front end to the back. I was like, wait a minute, like what's going on? Like this is a listener and a health check, right? Like, well, yeah, but you have these other concepts. So that one was probably the most confusing I've seen so far. But I'm also pretty biased because I've been in AWS worlds and on-prem with stuff for so long. That's what I learned from the beginning. So.
What I usually was doing was using the VIP stuff from Talos itself, and then you create a virtual port in OpenStack, which you put the floating IP on. So you make a port which has an internal IP, which you configure for the VIP in Talos, and then you don't need an external load balancer. But why not use an external load balancer and get that part of Talos? Yeah, it is an extra thing. It's a nice feature to have, but it is something that Talos really doesn't need to do. The other thing I usually do is that I do use IPv6 to get into my Talos without using floating IPs for my control plane nodes. So that I add IPv6 and that I have more strict security groups for my own IPv6 address in, so that you don't have to open it up for the world. But I still use the user data as you explained. Don't use the insecure, but use the user data. Get the configuration in beforehand instead of having started in an insecure mode and have it open for everyone that can connect. The alternative is, of course, using Omni and just have your image from your Omni installation and just start from there.
Right. And that having the WireGuard set AeroLink automatically is secure only over that connection. So you're not worried about like who can see what, who can say config. It's like, no, you have to go through Omni. You have to authenticate there. I actually recorded a video yesterday for it and I was going to post it and DaVinci Resolve is crashing on me. I think my new NVIDIA drivers are causing problems. So I'll get up an overview on why that works with Omni. But yeah, it's another option. And there's a lot of ways to do it. And depends on your setup and what you need. So.
I've been working on getting Omni to work in Kubernetes as well, not the Docker thing, and I have that working as well. So that's a cool project to talk about later.
Yeah, for sure. Like that's how we run the SaaS, right? Like the SaaS Omni runs.
I account on that.
Yeah. So cool. All right. Well, thanks so much, Pip, for walking us through it and showing us the OpenStack environments and getting it running.
You're welcome.
This is great. And thanks everyone for watching. Check out Pip's other videos and also like join the community. I know Pip, you're pretty active in the Slack. So jump over to the Talos community Slack. And are you going to make it to
us at TalosCon?
TalosCon. I was going to say, I was like, come over to TalosCon. We got lots more content. So
I'll be giving a presentation about OpenShift and Omni there.
Yeah. So we'll get the other OS infrastructure provider. It's gonna be great. So thanks so much, and hopefully we'll see anyone watching this in London in September. Talk to you later.
See you there. Bye bye.